Hey everybody, good morning. I'm going to do a quick video on an important lab that looks at the force of gravity. We're going to start investigating that in a little bit more detail. So now that you've done the lessons on all the different forces that we have to look at for this class and then how to put force diagrams together, we're going to start looking into a little bit more detail in each force. So this lab, we're going to look at the relationship between the mass of an object and its weight. They sound like the same thing, we often interchange them, but mass and weight are different. Mass is the amount of material or inertia. Weight is the force of gravity. It's the common word we use for that. We know there's a relationship between the two. You know that the more mass something has, the heavier it is. Heavier refers to the pull of gravity. So we want to get the exact mathematical relationship. So I'm going to take a spring scale, and I'll show a spring scale in a minute, and I'm going to hang various masses from that. The spring scale records the pull of gravity or the weight, and so when you have the mass and respective weights, you can make a plot between the two, make a line, and then get an equation, and that equation will be a very important equation throughout the year. Okay, so here is a spring scale. All right, so there you can see that the top it reads as newtons, and then for this one it goes all the way up to 5 newtons. I have different spring scales for heavier objects, and I'll switch to that when it comes to that. So I'm not quite sure how good the resolution is going to be, but you'll see that we have a 2 or a 0, then a 2, 3, or sorry, 1, 2, 3, 4. Okay, I can't see the mirror image of that. Anyway, you're going to want to read from the top of the plunger. So the top of the plunger, if there's nothing on there, should read close to that 0 line there. And if I look at it, it looks like it's a little bit above, so I'm going to make an adjustment, try to 0 it better. All right, so when you read this as carefully as possible. Each mark should be 0.1 Newton. Okay, so I'll switch over when I need to, but our first mass right here is 100 grams. So it says it right under, now that you can read that. So let's get the weight. I'll try to get this close to the camera so you can read it as best as possible. Okay, try to be as precise as possible. So there's 100 grams. Next, let's do 200 grams. So there's 200. Next, we're going to do 400 grams, so I'm just going to add another 200 to this. Okay, so there's the hanging part, just to show that I'm not tricking you somehow. And notice you want to keep it still, right? If I'm jiggling around, it doesn't sit. That's important, actually, something we'll talk about later. So there is 400 grams. Next, I'll go to a different, this is a 10 Newton scale. All right, so I'll go to 700 grams. So I'm going to take a 200 and a 500. And there is 700 grams. I'll do another 200 to that. So now we're up to 900 grams. I've lost track of how many different ones we've done. If I do above and beyond, not a big deal. So again, that is 900, no, I'm sorry, that's 800 grams, my bad. That's 800 grams. Let's go to 1 kilo. So here is 1,000 grams, big old mass. Gonna take us to the very edge of our scale. Okay, so that is 1,000 grams. And let's do one more for a good measure. Actually, I'm not sure that 1,000 grams recorded well, so let me do 1,000 grams again. I'll do the 20 Newton scale. In this one, in the 20 Newton scale, each mark is going to be 0.4 Newtons. If you look at this, it goes 0, 2, 4, and there's only 4 marks or 5 marks between, so it's 0.4 Newtons between them. So let's do 1,000 grams again. Okay, and then I'll finish off with 1,500 grams. All right, hopefully you can read those in such a way that you're not stressing out about this. I do want accuracy as good as possible, but I do understand there's some limits due to the nature of the filming here. Okay, so if you have any questions, let me know, but it should be pretty straightforward.